Good morning. Uh, First, thanks to National Federation of Sugar Factory to giving this me opportunity to present here. So, I will give just a small brief of RAJ process. RAJ process is 25 years old company engaged in design, manufacturing, erection and commissioning of process plants. We do turnkey systems for bioenergy, bioethanol, starch and liquid glucose, herbal extraction systems. We do the process plants for various process industry. We do the drying systems, evaporation plants, special mixers, high pressure reactors, and pollution control systems. RAJ process continuously developing new technology and tying up foreign companies for new technology. So now I am giving some idea about the future, sustainable future of the sugar industry. I will go in short. So current sugar industry, we are producing sugar, we are producing ethanol, and we are producing power. But if you want to sustain further, we need to produce co-products from that sugar products, sugar waste. So we can produce wax from press mud, we can produce biogas from press mud and spent wash, we can produce potash fertilizer from the spent wash, we can produce organic fertilizer from the press mud, we can produce hydrogen from the methane. That is also new technology. RAJ process had tied up with the German company where we can produce directly hydrogen from the methane. Then we can produce methanol from CO₂. We can produce nano area from the distillery effluent. And we can produce 2G ethanol from the biogas. We can produce SAF. So there are many products that can be produced from sugar waste or sugar available feedstock. So potential of this feedstock, if you see, India, more than 500 plus sugar industries are there, and they are producing 12 to 14 million metric ton press mud per year. And from that press mud, we can produce approximately 6 lakhs ton CBG per year. We can produce 3 to 5 lakhs wax per year, and we can produce FOM from that press mud. If you see India, we are around 350 plus distilleries are in India, and we are producing 5 to 6 billion liters of ethanol from the molasses or syrup. So in this case, we are generating around 50 to 60 billion liters of spent wash. And this is the waste of the sugar industry. And from that waste, we can produce 6 lakhs ton CBG, and we can produce 25 to 30 million metric ton PDM. So this much potential we have in this sugar industry. So RAJ process has installed all pilot plants to demonstrate these processes. So we have pilot plant for manufacturing of the biogas from press mud and spent wash. We have pilot plant for manufacturing of the hydrogen from methane. We have pilot plant for manufacturing of wax from press mud. We have pilot plant for 2G ethanol, and we have pilot plant for carbon capturing. So we have installed these pilot plants in our facility to demonstrate the actual operation of this process. So today now I am talking more about the CBG from the press mud and spent wash. So why CBG from sugar industry? Because this CBG will increase our revenue of sugar industry. It will reduce the pollution and waste. It's a circular economy. It supports energy security, and it will help to rural development also. So RAJ process, what we do for that? So RAJ process do that biomethanation of the press mud and spent wash. We upgrade that raw biogas and making a CBG, we produce the byproducts like potash-rich fertilizer, we produce elemental sulfur, we produce liquid organic manure, and we So biomethanation, the first step of the making the biogas is the biomethanation. So biomethanation, I think everybody knows about this. This is the CSTR technology. So continuous stirred tank reactor, where we degrade the organic matter. So in this, there are process steps like hydrolysis, where we broke the organic material, then acidogenesis, where organic material converts in the acid, then acidogenesis, where acetate is from the organic acid, and methanation, where methane is produced from acetate, hydrogen, and CO2. So this is a completely biological process where we generate the raw biogas. Generally, composition of raw biogas in the case of spent wash, we have the around 55 to 60% methane, 30 to 35% CO2, 4 to 5% H₂S, and other components. And if you are producing the biogas from the press mud or other feedstock like organic feedstock, then in that case H₂S is less. It is around 1500 to 2500 ppm. So this is the technology. This is complete hybrid technology. RAJ process has developed to purifying the spent wash biogas. So basically, if you see that the spent wash having more H₂S and production of H₂S, removing of H₂S from the raw biogas, it is costly. So in this case, we developed a biochemical process. In the biochemical process, there is one reactor, it's column, where inside there is packings. So we use the lean caustic water for the scrubbing. In that case, the lean water caustic is sprayed from top of the column and raw biogas feed from bottom of the column, where there is contact between gas and liquid, and in that contact H₂S is absorbed in this lean water caustic water, and hydrogen sulfides is formed there. Then in that case, the hydrogen sulfide with rich hydrogen sulfide water falls down below the column. Then we take this liquid in the bioreactor. In the bioreactor, we oxidize the sulfur and we generate the elemental sulfur, and we regenerate the caustic. So in this case, there is maximum 3 to 5% additional chemicals required instead of 100%. So in biochemical process, basically we are regenerating caustic and we are reducing consumption of the chemicals. And in that process, finish. Yeah. In this case, the liquid of generated caustic liquid again recycle back in the process. So this is a continuous process where we are not generating effluent, we are just producing the elemental sulfur as a byproduct. So in second stage, when we want to remove the CO2, there are specific requirements to dissolve the CO2 in the water. There is some specific temperature and pressure. So it is a chilled water scrubbing process where we put the chilled water in the top of the scrubber, in the CO2 scrubber, and we put the CO2 and methane mixture in the bottom of the scrubber. In that case, we increase the pressure of the gas by LP compressor, and we reduce the temperature of the water by chiller. And in this process, again, the chilled water spray from top to bottom and gas flow from bottom to top, and the CO2 dissolves in the water. So CO2 rich water falls down, and then we take it in the CO2 stripper. In the CO2 stripper, again we exhaust the CO2 from the water, and we use the same water for the process. So in this case also, there is no effluent generation, there is no water droplet outside the process. So in this case, the methane purity we got around 97 to 99%. So 99% purity pure methane, we take it in the dryer, where we reduce the moisture, and then we store in the buffer vessel. After buffer vessel, if you want to sell in the cascade, then we need to compress it up to 250 bar. So for that, we are using HP compressor, and we pressurize it up to 250 bar, and we fill in the cascade. So this is complete technology systems, hybrid technology. RAJ has developed and now RAJ has supplied many plants for that. And these plants are running well.
Sir,
So,
we request you again, please conclude.
yes, yes, last. So now, why upgradation we are doing? We are increasing the caloric value from 4,500 to 9,000. It is replacement of industrial CNG, high returns of the gas, supplementary of fossil fuel, CO2 emission will be reduced in this case, and can feed to gas network directly. So this is the analysis of the product after removing H₂S, and this is after removing CO₂. So we achieved around 98.94% pure methane in this process. So methane slippage. Actually, methane slippage is a very important phenomena in the technology, because there are many technologies and there is many technologies have different slippage. If you go for VPSA, there is 5 to 10% slippage. If you go for membrane, there is 3% slippage. But in our case, it is maximum 1.6% slippage we found. So this is because of the criteria, tendency of the mixing of the CO₂ and H₂S in the chilled water. In the chilled water, CO₂ mixed 37 times than the methane. And considering that proportion of both the gases, it is around maximum 1.6% slippage of the methane in this technology.
Sir, please.
I am finishing now, sir. So just I am giving the short comparison. There are biochemical and chemical technology for H₂S removal. So H₂S removal, if you use the biochemical technology, we need 5% chemical, and chemical technology, we need 100% chemical. And it generates waste effluent in the chemical technology, and in our case, we are generating elemental sulfur as a byproducts. Then again, there is comparison between chilled water scrubbing, membrane, and VPSA. Basically, maintenance cost. In membrane, we have to add some membranes modules after some period, and after some years, we have to replace the complete membrane. So that case, the membrane maintenance and membrane replacement cost is major cost in this technology, where in our case, there is no maintenance. We can run this plant 20 years continuously without doing any maintenance, because it's complete stainless steel equipments. So that is, I will go fast now. The post-treatment, actually after biomethanation, we need to treat the liquid. And the biodigesters, in the case of spent wash, we do it's a drying, and we make a potash powder. And in case of press mud also, we do the drying and we make the organic fertilizer. So this is the composition of the spent wash, where that basically contains 18 to 20% potash, it contains 30 to 36% organic carbon, it contains nitrogen. Yeah, finish. So for this CNG project, government also some subsidies. So you can have this 10 crore subsidy in SATA scheme from the central government, and there are some subsidies from state government also. So I will go in fast there. They are providing transportation cost also for this. And basically commercial aspect, because in sugar industry, the spent wash is effluent, and press mud also there is quantity available. So from that effluent, we are producing the products and we are generating revenue. So it is good for the sugar industry, and we have potential of 62 million metric ton per annum production of the CBG. And now government is giving 85% cost of the production in the market price, and raw material is available. So there is a we have the minimum cost of the raw material. So payback of this process is within 2 to 3 years. So we have some clients. Yeah. So we have commissioned our first plant in Jakrai Sugar in Maharashtra, 20 TPD. That is commissioned. Then VNP distilleries in Karnataka, Hubli is commissioned. Then Shankar Marshi, Shankara Kolle, Sakari Sarnakar is also commissioned. And around 5 to 6 projects are under construction. And around 15 projects in the other feedstock as a Napier grass under construction.
Thank you, sir.
Thank you, sir.